interesting thing that you mentioned now is about the user interface. I know that part of the idea with objects was also to enable graphical user interface things, right? Is that correct, or am I getting...
Well, if you go back to Smalltalk and the Xerox PARC work, clearly part of their vision was always that the Dynabook or what have you, these little tablet-like things that people would carry around, that they would have sophisticated user interfaces, and in particular, they wanted the text to look as good on them as they would look on paper and such. And so, yeah, so they wanted very sophisticated both presentations, but they also wanted to be very interactive and such. And so that was really one of the first uses of object-oriented programming, and particularly with Smalltalk, was to build those systems, those systems with modern user interfaces, or actually invent those sorts of modern user interfaces.
Right. So we were about Tektronix. We paused a bit when the teams started working in Smalltalk and started developing things and so on. But I guess there were some other developments afterwards.
Yeah. So we basically, based upon the work I did to make Smalltalk fast enough to be usable, and the experience in tech labs, computer research, and all these researchers using it and stuff, we decided that we wanted to get this out to the broader world. And so we actually, starting with me and some people in the research lab, and then spreading out to one of the product groups, we actually developed a plan to develop a product that was a Smalltalk product, basically. And we developed from between 1984 and about 88, 89, a family of desktop machines that were optimized to run Smalltalk. This was called the Tektronix. The first one was called the 4404. It was the 4400 series of Smalltalk machines, and that was sort of they were sort of the first professional quality, affordable as in they only cost like $10,000, but they're the sorts of things people could buy multiple units for a research group or an engineering team and stuff in industry and stuff. And plus we gave a bunch of them away to various universities and such. And so they established, they actually became the first machines that actually exposed a lot of notable people in the object-oriented community to object-oriented programming and such. I mean, at Tektronix, people who are at Tektronix, in addition to me, while we were doing this, and we're kind of got the Smalltalk bug, were, there was Rebecca Wirfs-Brock, of course, but then Ward Cunningham, Kent Beck, they were all Smalltalk people at Tektronix. Ralph Johnson at the University of Illinois, who was one of the Gang of Four, we seeded him, his group, a bunch of machines to do research, and so there was a bunch of Smalltalk stuff at the University of Illinois that came out of that. Tektronix actually used Smalltalk to build the user interface for a couple of series and generations of oscilloscopes that were programmed in Smalltalk, and that work was done using some embedded system-oriented Smalltalk tools that were developed by a company called OTI, Object Technology Incorporated, headed by Dave Thomas. And OTI and Tektronix was kind of one of their first major customers, so we helped get them started. And OTI went on to become the creator of IBM Smalltalk, and eventually was acquired and became part of Smalltalk. So there was other things that came out of what we did at Tektronix was so like the OOPSLA conference, which over the ACM OOPSLA conference, which became kind of the major object-oriented technology conference. I was one of the original co-founders of that, and the first OOPSLA was held in Portland. So there's a lot of stuff like that. That really that happened in Tektronix over that period. But the thing that what happened at Tektronix was fundamentally a hardware company. They built devices, they literally bent metal. I have an original 4404 Smalltalk machine down the hall here in one of the rooms here of my house, and it is metal, and it was bent into a shape and put together. It's like a battleship and stuff. And so there was a period in the 80s where there was a market, a business could be made for selling specialized computers, so like Smalltalk machines and Lisp machines and stuff. But as commodity computing hardware got faster and faster, first commodity workstations and then just commodity PCs became fast enough to do practically anything. And so there really wasn't a business anymore in terms of building machines, specialized machines and specialized things. And so eventually Tektronix decided, well, they really didn't make any sense to be building these Smalltalk machines and stuff. And since building machines is what they did, that was kind of the end of that. And that phase of what happened at Tektronix, and then from Tektronix, lots of Smalltalk people. I talked about some of them went off and kind of fertilized the world. One of the things, I'll give you another little story. So most people are familiar with pair programming.
Yes.
Right? So have you ever heard the origin story of pair programming?
No, actually, no. That's interesting.
I'll give you the origin story of pair programming. So in tech labs, computer research, where all these people are doing stuff in Smalltalk, one of the researchers there was Ward Cunningham. And Ward, people who know Ward, is a very innovative idea. He's always coming up with a fresh idea and stuff. I've known Ward for decades, obviously, since I'm talking about this time period. But so Ward is a very innovative guy, but he's so creative. Maybe his attention. Some people would say his attention span is short because he started working on something and then get another great idea, and so in the mid '80s. So he was there working on using Smalltalk and tech labs and actually doing lots of pretty incredible things. And a new, I think, master's graduate from the University of Oregon got hired into the lab, in the tech labs. His name was Kent Beck. And well, I'm not sure exactly how this worked, but Ward kind of latched on to Kent as his protege, or maybe Kent latched on to Ward as his guru. But at any rate, they became kind of programming buddies,
Mm.
and in particular, what they would do is they would go into Ward would get an idea, and he'd grab Kent and bring him into his cubicle. And Ward was saying, I was thinking that we could build, here's a way we might be able to build like graphic editors in Smalltalk. And we take this object that has these control points, and if you drag and drop on the control points, you could do, something like that. And Ward would, and Kent would be there, and Kent would say, well, let's write some code. And so they type a little bit of code and they try something, and Ward would say, well, that's pretty cool. What if we did this? And Kent would write some stuff. And so working together, they would sit down and sort of prototype that stuff, working as a pair, and pair programming. That's where it came from. pair, so eventually, so Kent in particular went on to like the D3 project at Chrysler, and out of that came extreme programming and stuff. And one of the tenets of that was pair programming. Well, what's the origin of pair programming?
Yes.
Pair programming is how Ward and Kent would work in tech labs.
Yeah, that is. I mean, I had a friend, David Hassman, who unfortunately has passed away last year, but he used to tell me that story that he was doing music before starting programming. And often in a music studios, the devices were very complex. And so they had to work together. And he was funny. He was always saying, yeah, pair programming, we call that working together. It was just a very simple idea. And as we can see, these ideas are very, very useful. Now, about Smalltalk, we cannot end a discussion about Smalltalk without mentioning that afterwards, I guess the mantle for object-oriented programming was taken first by C++ and then by Java and C#. What happened? Why didn't Smalltalk move on?
Well, so I mentioned kind of that the era of the standalone Smalltalk machine kind of came to an end. And that was also the beginning then of the era of commercial Smalltalks that ran on conventional stations, conventional PCs and stuff. And so I and a group of people at Tektronix went off, and we started a company called Instantiations. There were the people at Xerox, some people from the original Smalltalk group at Xerox PARC spun off, and they started a company called Park Place Systems. George Bosworth and Jim Anderson and a couple other people started a company called Digitalk to build Smalltalk systems. Mentioned OTI and Dave Thomas, and eventually became IBM Smalltalk. So there was, from 1990 through 96, let's say, there was a real commercial Smalltalk market with multiple companies building Smalltalk systems and trying to sell them. And they did sell them. But what turns out, so two things had to go on over that period. One of which, Smalltalk had to be transformed from this kind of research exploratory programming environment to something that could be used for IT-style software development. And the reason why IT-style software development? Well, it's because back in those days, at least, if you started a software company and you said, now who are my customers are going to be? Who's going to buy stuff? Um, the the number one possibility to pop up was IT organizations and big companies because they
Yes.
spent and still spend lots of money on software development products and tools and services and stuff. And so you needed to do stuff that would appeal to those people. And one way to think about it, in the early 90s, you could sell a Smalltalk environment, a Smalltalk programming environment for a single programmer to an IT organization for about $2,500 per person.
Hmm.
Well, if you're trying to sell to consumer PCs market, you could maybe sell the same thing for, well, if you really wanted to sell a bunch of them, probably $99 would be the price point you'd want to shoot for. So it it turned out that you could you could make a lot more money selling to those IT groups and a lot more predictably than you could to this emerging PC market, right?
Yeah.
Uh,
Consumer. Yeah.
right. So there was a lot of technology development had to go on in Smalltalk to make it more suitable for sort of professional programmers doing IT style projects and stuff. And at instantiations, that's a lot of what we were actually focused on when we started was tools that were allow kind of multi-person projects to work on Smalltalk and stuff. Which the original Smalltalk, we didn't talk that much about the virtual image, but it was essentially a single person environment and stuff. And so if you need something that had 10 programmers working on the same thing, Smalltalk didn't have a lot of tools or a lot of guidance for
No.
how you would coordinate the work of all those people. And so that was a
Yeah.
big area that my team focused on for a number of years. But so during that period from 1990 to 96 or so, um, there was actually a lot of commercial activity with Smalltalk, a lot of big companies using Smalltalk for IT development. Banks, major banks, financial institutions, insurance companies, railroads, just all sorts of big IT style projects and stuff going on. And now I'll say something that after the fact, a conclusion I came to.
Hmm.
Why were these people buying small? What did Smalltalk offer them? What did they think they were getting for it? So certainly in terms of marketing, there was all the Smalltalk companies talked a lot about productivity and software reusability, and because everybody's always worrying about those things, it's a perpetual problem.
Yes.
Whenever we saw, whenever we as technologists in this field, whenever we make it possible to deal with some more complexity, or people just build up to the, they consume all that available complexity management until they get to the point where now they're doing even more complex things and they don't know how to deal with it. So it's a perpetual thing. That's kind of like the story about the failure of object-oriented programming. No, it didn't. Just that we've consumed all the complexity management it made available. Now we're doing even more complex things. We need
Yes.
techniques. So that was a big pitch of the software companies. Was all this the software engineering advantage of it and stuff. What I ultimately concluded is that the vast majority of those companies in buying tools, what they really wanted to do was to build systems that had UIs that looked like they were running on a Macintosh. That was really what they wanted to do. They wanted to put a modern Macintoshish style user interface on these corporate applications they were building. And what they in some cases were told, in other cases just came to believe that to do that, they needed to do object-oriented programming. That
I
object-oriented
see.
programming was the essential technology for building a multi-window GUI style interface, and the best object-oriented programming environments were Smalltalk.
Now I can
And so,
understand why the videos I saw. I found some videos presenting object-oriented programming, and the focus was a lot around the user interface, the graphical user interface, that you can build it, that you can. And I think Steve Jobs also said something around these ideas of having objects to use the graphical user interface. It was a message he was sending back then. That makes a lot of sense. Yeah.
yeah, because literally, these organizations who were the customers, they were what they had been doing for the previous 20, 25 years, and their staffs, their technical staffs, there were people who were building punch card oriented systems programmed in COBOL or assembly language. And suddenly they were being asked to build these magical user interfaces. They
Mm.
had no idea. They had no idea what they needed to do, how to make that transformation and stuff. And so when you show them something like Smalltalk and said, see, here's a system where you can program those sorts of applications, and here's how you do it. They would literally, in those years, there were companies who would say, okay, I have 100 programmers in my shop, so I'm going to buy at $2,500 a seat. I'm going to buy 100 copies of your Smalltalk development environment. Okay, and so these were companies. These were at that time in the early 90s. They were rising star development companies, and rising star kind of startup companies that some of them went public and stuff, and there was significant venture money involved in these companies and stuff. The actual big competition during that period wasn't C++, in this, which was the other kind of emerging sort of object-oriented language. It was actually Visual Basic was the big competition.
Yes.
Okay, Visual Basic, because again, it was targeted the same thing for these IT customers who say, here's how you can easily build
Interfaces.
these apps. But so there was a period in probably 93, 94, 95, when where in the technology press, people were talking about Smalltalk as the successor to COBOL for the IT. And that's why IBM acquired OTI, and they basically, IBM said, yes, Smalltalk is going to be it. Smalltalk is going to run on all our machines, from the biggest mainframes down to personal computers. And it's like the key programming language technology for the future. And so Smalltalk was doing quite well. And by the way, there are still hundreds of mission critical IT deployed IT applications that are implemented in Smalltalk and still being run.
I can imagine. So how comes still that, I guess when I first started to learn programming, the first programming language was BASIC, because we had ZX80 clones in Romania. So, and they were running BASIC, and you could immediately after booting up the machine, you had BASIC. So you had to learn how to use it from command line using this language. Then I actually learned a bit of Logo, which was also available on ZX80. But then once I got into learning more about the professional programming languages, first was Pascal, kind of the educational language that introduced everything. But then the next one was C++. We did nothing about Smalltalk at all. So I guess something happened somewhere that made C++ at least more, how to say, more interesting for universities or for the industry. I don't know.
Well, so yeah, I mean, one of the big differences between Smalltalk and C++ is that C is a statically typed language.
Mm-hmm.
Smalltalk is a dynamically typed language.
Yes.
And there's always been statically typed languages have been perceived, whether or not this is truly the case, is debatable, but has been perceived to be more reliable because you could find they do error check. The perception is they do error checking before you run a program.
Yes.
While dynamically typed languages, the error checking occurs while you run the program.
Yes, and it's interesting because when I first started C++ and all the strongly typed languages, they were more interesting to me, and I couldn't imagine using something else. But then once I learned programming better, now it's much easier for me to write Python or Groovy or anything that is not as strongly typed. It's actually loosely typed, dynamically typed. I write the code that I want, and it's up to the computer to figure out what I wanted to do, and not me to figure out all the nuts and bolts of the types and so on. And we are still having this conversation today in our groups. There are some people who prefer very strongly typed language. I'm going on the other direction with loosely typed.
Yeah, so I prefer to say dynamically typed, but that's it's fundamentally, I think, it goes back to the model I described originally, which is the difference between discrete event simulation and continuous event simulation. And that's the split of the world of computing is are you working in a world where you think everything can be well defined before you start and is understandable, and so you can sit down and precisely describe everything that's going to happen? Or are you working in a world that is too complex for an individual to understand? and and so let's not try to understand the whole thing. Let's not try to pin down every loose end. Let's build pieces that compose and work together, and see if we can make that work.
Yeah.
And so
that makes a lot of sense to me, and it's quite interesting to see this split, because now I can understand why in certain domains you can use things like strongly typed and C++ and you can optimize for speed, and you can, because you know everything that's going on there, you have mathematical model. You can do this in some engineering applications, in some in games, presumably. These are quite okay to do in this way. But then if you are doing something that requires more faster development, and you are exploring and you have no idea actually or less of an idea what you're trying to build, and it's much easier to go with other types of programming languages. And to me, please.
I was going to say games is actually a great example because games have both aspects.
Yes.
Right? You talk about the game engines and how you do 3D graphics rendering and move things around on the screen. Well, that's something now that's quite well understood and has an underlying a mathematical model that can be applied, and then so that's kind of the continuous simulation side of the world. But then the actual gameplay, the internet, you know, how do the characters interact and stuff? That's much. Again, that's more chaotic. It's just things interacting in ways that, well, if you could pre-imagine, if the game designer could pre-imagine how everything would work together, it wouldn't be the games would be less interesting, right?
Yes.
Stuff and so you often in game environments find a more dynamic language that's used at the higher levels for describing scenes and interactions and gameplay and stuff, and those often are more dynamic languages.
So this takes us to the next interesting topic. You are part of the JavaScript Standardization Committee and actually led part of it. And I think JavaScript is an interesting example because it's one of the programming languages that's on everybody's computer, whether you know it or not. I know the efforts that have been put into, for example, standardizing C++, now evolving it in the past years much faster than it used to be before. But I guess it's very similar, if not a larger challenges for JavaScript, because you have so many different clients, so many people using it, without knowing sometimes. This has to be an interesting thing. And also, JavaScript is also hated often for various weird things in it. Which come, I imagine, from historical reasons and so on. So, what is your role in JavaScript, and what can you share about this?
So I need to put in my commercial here. So this is the story that's covered in my 190-page paper, which
cool.
I'll give you a link to so that you can put up so people download it and stuff, because it actually tells the whole. It's called, actually, the title of it is JavaScript: The First 20 Years, and so it really tells the story from 1995 to 2015 of Smalltalk of JavaScript's creation and evolution and standardization and stuff, and so there's a lot to talk about there. So I'll just touch on a couple little things to get to fully answer your question. Is what that paper is, or what that, I know calling it a paper is kind of silly, but that's the ACM called it. Yeah, I guess the first thing I'd say is, so what happened to Smalltalk? Well, the internet happened to Smalltalk is basically, I would say to a large degree, the Smalltalk companies were so focused on the serving the IT market, doing kind of client server applications and stuff. They kind of missed the whole emergence of the internet and web browsers in particular, and browser technologies. One of which was JavaScript, of course, and another one, not really, but they were able to cast it to market it as an internet technology, which was Java. And so those technologies, particularly in the late 90s, but not necessarily beyond that, Java was marketed as object-oriented language. That's great. Built for the internet. That's the
Yes.
hot new technology. Uh, and literally over less than a 12-month period, Smalltalk went from being the hottest new programming technology out there to a legacy language that was, used to maintaining existing, enterprise applications. And what took its place in terms of mind share for innovating programming environments was initially Java,
Mhm.
not JavaScript, but Java.
Java, yeah.
With Java. And there's a whole story to be told there about why Java programming and how Java programmers think is quite different from how Smalltalk programmers think and such. But 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 getting to the real point about JavaScript is that lurking behind all this, in fact, ultimately the thing that's more successful than either Smalltalk ever was or even Java is JavaScript.
Yes.
Because as you say, JavaScript is literally on every machine of interest anywhere, and there are uh, basically there's statistics floating around that like 70% of programmers in the world know how to program in JavaScript, and I suspect it might even be higher, than that. But it's it's like everybody knows how to do JavaScript. Uh, and why? Well, it's because JavaScript ended up being the language that was integrated into the browser platform.
Yes.
And, and there's all sorts of interesting reasons why over a 10 to 20 year period, JavaScript emerged as the dominant language. But there's a couple unique characteristics of the web, of the browser platform. First one is that there are multiple browsers. There have always been multiple browsers that were independently implemented
Mhm.
that were expected to be able to provide access to all the web pages that exist in the world, right? Because what people found, I mean, the early browser wars between Netscape and Microsoft, they tried to position, well, it's better to use Netscape or it's better to use Internet Explorer because more things will work with it. Well, that's not what users want. Users just simply want to say, well, I'm using a browser on whatever machine I'm using, and I just want this web page I'm accessing to display right or to work right, or this web app to work right and stuff. I don't want to have multiple browsers installed and choose a different browser for a different application and stuff. So I want to be able to use any browser. So that requires that there be multiple independent implementations of the browser technologies, including JavaScript, and they had to work the same. There couldn't be variation. Where traditionally in programming languages, um, there would be different implementations of C or different implementations of Pascal. The languages are actually specified in ways that allow implementations to make different decisions, to do certain things slightly differently and stuff, so they get optimized or make them
Mhm.
fit more easily in different environments and stuff. And the assumption being that, well, if you took a C program and you moved it from, you moved it from from a mic from a PC using Microsoft C, and you moved it to a Unix system. Um, when you did that, you would test your program and you'd find any differences before you deployed it to your users, and and so it was okay to have little differences and stuff. But um, this is kind of the tale that Douglas Crockford, the discoverer of JSON, is how he characterized himself. Says right. So if you take that model of the world, that traditional model of the world, if the programmer chooses the deployment compiler for the language he's going to use and tests it before he deploys. With JavaScript on the web, um, the the end user chooses the deployment compiler by choosing which browser he's going to use. And so if you're a developer and you're going to deploy a web application written in JavaScript, it's really impossible. Pragmatically, you can do it on the most popular, but it's impossible to test on every browser and every version of every browser that any user might use. And so you depend upon that the implementations in the different browsers are going to work exactly the same on this code you write. So in the early days, that didn't work so well, right? So, and people discovered that was a big problem. Um, and both the browser implement vendors, people who built browsers, had to discover that actually it would be important for them to all work the same, and then they had to figure out what does it mean to work the same. And that was where standards came into play. So
Mhm.
very early, within a year after the first release of JavaScript, there were efforts underway to define a standard that would describe at a very detailed semantic level exactly how this language worked so that everybody could implement it exactly the same way. And that really, over this following 20 years, that's been one of the things that the standardization of JavaScript has been about, is about evolving or moving the language forward in a way that ensures that every implementation will behave exactly the same way.
Mhm.
So that's one really important aspect of it. The other important aspect of it is that historically, as languages evolve, they break. As languages evolve, as you get a new version of a language, they tend to introduce incompatibilities with previously written code. And the assumption is, well, when the developer chooses to move from a version 1 to the language and a compiler for version 1 to version 2 of the language and a version 2 compiler, they'll make any changes they need to the source code so it will be compatible with version 2. Well, with web applications and web pages, there are millions of web pages sitting out on servers that nobody has touched in the last 20 years. Nobody has done any maintenance on them in the last 20
Oh,
years.
yes.
Okay. So that if you think of as the web collectively as a repository, as a kind of a human digital legacy repository, everything since 1995 pretty much that has been done in the digital realm is out there on the web somewhere. If you want to preserve that, then those things that were written 20, 25 years ago, and it's not just things in a server. You sit about things that are sitting in like the web archive wayback machine and stuff,
Mhm.
that were captured in 1996. And if you bring that up on your browser, you still want it to work. So one of the slogans in JavaScript standardization, and actually it goes beyond JavaScript to kind of web standards, is we say don't break the web.
Yes.
That as you evolve and move the technology and add new features, you have to do it in a way that doesn't invalidate things that already exist sitting out on the web and for which there's nobody out there to do any maintenance or to fix it. And so there's a strong bias against doing anything that will break any existing code. And so in terms of evolving the language, you kind of have these are boxed in by these constraints, not breaking existing things. You have to do things in a way that can be precisely replicated on every implementation. So that's a big part of what JavaScript and web standardization is all about. And the reason and why only so another thing people ask is, well, why don't we have multiple languages? In the browser, why is there only JavaScript? Well, one reason is basically for those various reasons. It's much harder to do that for multiple languages than it is for one language.
Yes.
Right. So if you think about the investment it would take to add a new language, you might call it Tart, for example, or something to web. So everyone who builds a web browser would have to commit to building that and adding it to their browser. They would have to say, well, once this is here, people are going to start using it. That means I'm now committed to supporting this forever.
But there's an interesting case still. I know about WebAssembly. I haven't looked a lot into it. But it seems to be, I mean, from my perspective, I started thinking at some point about the browser and because most of the web applications today are basically a reiteration of the desktop applications. They start to work in the same way. They start to have rich interactions and all that. And therefore, the browser becomes more or less like an operating system for the web. And in that case, of course, having something like an assembly language for that would make a lot of sense. And I guess that's where WebAssembly is coming from. And it's interesting when I hear you talking about this, it's interesting to see that still companies have taken this on. I guess there are some advantages of having this.
Well, so that was a very tricky technical and political maneuvering to make that happen. Okay, because there had been prior attempts to either add additional languages to the browser or support additional languages as plugins or to build other kind of low-level virtual machine style interfaces into the browser, which for both technical and pragmatic kind of business reasons never really got off the ground. And mainly tied to those two principles I mentioned, is that you have to ensure universal interoperability, and you have to ensure perpetual maintenance, perpetual support of past things. So what people discovered, so for quite a while, it looked like the only thing that could run in browsers, that there would only be JavaScript. And so people in the late 2000 knots, 2006, 2007, 2008, started saying, who wanted to run other languages said, what if we just compiled to JavaScript?
Yeah.
Right? And so people started building what came to be known as transpilers that would compile to JavaScript, and including transpilers for C and C++. and it was, they discovered that if you had a good high performance JavaScript engine that was good at doing essentially numeric arrays and stuff, and you were tricky about how you compile the C code into JavaScript, you could get the JavaScript runtimes to optimize the code, since the runtimes are all basically just-in-time compilers, and get code that was almost as good as running natively compiled C code or C++ code, but in the browser compiling through JavaScript. And people, people discovered they could do things like they could host Linux on a web page,
Yes. Yes.
right? By compiling it to JavaScript, and they could host. One of the drivers of this was game engines.
Yes.
Like I think it was the game engine and stuff was they said they could compile the C++ code to Java, and there were some issues with startup times and stuff. But once it was running, it was they had run this C code to into JavaScript, and it was basically more or less fast enough. And what people realized was that the JavaScript engines that were there had the capability to run this code that was written in different languages, then translated to JavaScript, and to stylize JavaScript, if you will, JavaScript that almost looked like assembly language, and that was very right. You do simple operations and assignments, and only use certain things. And that code turned in that the runtimes are smart enough to recognize the code and optimize it quite similarly to what just a native C compiler would do. And so if you will, the way WebAssembly was sold to the browser builders, the browser developers, as something that would be feasible to do, was not as let's add a new virtual machine to the browser platform, but as let's define how to use your JavaScript engines as a virtual machine that can be a compilation target for other languages. And instead of requiring people to compile to stylized JavaScript, which was then compiled, we'll just define a set of bytecodes. Literally they are. We'll define a set of bytecodes that can be ingested by JavaScript engines, just like they would have ingested the stylized JavaScript code, and then processed and optimized and run. And that's what WebAssembly is, basically. So
to go back to the standardization for JavaScript, because you mentioned the two big hurdles, and these are huge. I mean, there are quite some limitations. How do you deal with these things? So you probably got a lot of proposals for improvement or things like this, but then there's a whole process of figuring out how to insert this in a language, presumably convincing browser developers to adopt them, and so on. How does this work?
So it took the JavaScript standardization community, the standards group that does JavaScript, ECMA TC39 it's called. It actually took them over 10 years to understand this problem.
Oh.
So there was in the late 90s, there was an early standardization efforts that did a pretty good job of defining the JavaScript that it initially was created in 1995, 96, and 97, and describing it precisely enough that people could implement it and stuff. But there was this, and this wasn't just about JavaScript, it was about really all web technologies. There was a lot of dissatisfaction with what was there. If you remember, this was the same period when HTML was going to be thrown away and replaced with XHTML, right? And there was, in the JavaScript community, there were efforts to say, well, we're going to define JavaScript 2 or ECMAScript 2, the next incompatible version of the language. And the people who were doing that and the committees and stuff didn't understand these kind of two basic principles I talked about, because the web was still developing, was still young and stuff. And so a lot of energy went into defining what essentially were new languages that were loosely related to the original JavaScript and branded as JavaScript, but it's, we would say the difference was, well, it's really more like the difference between C and C++ rather than, so that took about 10 years. And actually, I first got involved with the standards at the end of that period as kind of as a dissenter representing Microsoft, but I was suggesting, I had suggested to Microsoft that they needed a dissent, saying, no, we don't need this kind of redesign. We don't have enough time here to talk about all the details of what was being proposed and stuff, but so kind of radical incompatible changes to the languages was not what the web needed. What it needed was kind of careful, incremental, ongoing evolution. And eventually the standards groups came to agree upon that. And that's kind of how we got to the existing versions of JavaScript, is that you can add stuff. You have to be very careful to add it in a way that is both fits in with what's already there, that won't break anything that exists, and that you're going to be happy to live with forever and stuff. And particularly the last 5 years. So a big part of that is whenever some new person gets involved, they have to be kind of indoctrinated into that way of thinking, because quite honestly, in most cases, somebody gets involved in the standard stuff is because they have an idea they want to push. I think we should get rid of all the object-oriented stuff in JavaScript and make it into a pure functional language. Somebody might come in like that. Probably more than one somebody's probably showed up and come in and said like that. And you got to say either. And when that happens, the community that's there has to either educate the people and say, well, no, that's really, we can't really do that, and get them so they understand that they can't really do that, but say, well, but maybe there's a functional feature that we could add, and so that's really what's going on, and it's actually very hard. It's quite challenging, because when I got started in 2007 is when I got involved with JavaScript standards. A typical meeting of the standards committee was like 10 to 15 people. And it was a small group of people that kind of changed relatively slowly, starting starting around 2014, 2015, um, people became much more, many more organizations and people became interested in participating in the process. And so now there's well over 100 people
Oh.
who consider themselves to be active participants, representing representing maybe 30 or 40 different organizations, but who consider themselves to be active participants and stuff. And so there is there's more of a process involved now. That process, is designed to both enable people to develop and incubate new good ideas, but also to have ways to shut down and close off not so good ideas as they develop and stuff. And there's still just a whole lot of kind of culture involved of acclimating people into this and stuff, and getting people to understand that just because you could do something to the language, a lot of people become involved who are not experienced language designers. And something that good language designers earn relatively quickly is just because you could add a feature doesn't mean you should add the feature.
Yes.
Or another way it's said, I'm not sure who said this exactly, but it's the most important decisions a language designer makes is the things they decide to leave out as opposed to the things they decide to put in. And so,
yeah.
That's very much a challenge now, because people want to be involved because they want to put things in, but yet if you put in everything that everyone thinks might be a good idea, you would have this incredibly bloated language.
Okay. This has been a very interesting conversation, and I'm sure we could go at it for hours. What I'd like to do is, before we close, I know you are writing. Recently, one of your interests lies in ambient computing. So maybe one or two ideas that you find interesting today around this.
So I'll just, particularly before I started working my big paper here, I was putting a lot of time into that. So here's the big thing. Here's the thing I'll say about ambient computing that I think is important for people to think about. If you think about how the nature of computing changed when we went from IT batch computing to personal computing, and that if what we now think of as the personal computers, or the personal computers each of us have sitting in front of us right now, is nothing like in any way in terms of what they do, how the software works, how people interact with them, nothing like what mainframe computers were doing just a couple of years before these personal computers occurred, and what people at Xerox PARC and with Smalltalk and at Tektronix and other places and Apple did was figured out what it really meant, what people needed a personal computer to do, and how is that totally different from mainframe computing before. So the challenge I kind of throw out to the world is we are true, and it's more obvious now than it was 5 years ago. We're moving into a world where we're simply surrounded with computers. Computers are everywhere, and they aren't just isolated to these personal devices that are sitting in front of us. There's still a place for word processors and all that stuff. But the real question is, what does it really mean to live in an ambient computing world? What is the nature of the software? what is the nature of the user-facing software? What are we going to do with it? What sort of system software do we need? What everybody naturally does is, well, just how do we incrementally build upon what we've had, starting with personal computers, and that's kind of when we get to mobile phones and tablets. They're, they're a variation of what's happening in personal computers. The interface style has changed somewhat, but they're still largely the same. But I'm really saying, well, what's what's the discontinuity going to be? What's the discontinuity, like the discontinuity from
Mm.
mainframe computers, personal computers? What's the discontinuity that's going to create a truly ambient computing world where we don't think about computing at all? We simply live in this world of information, and how's that going to work and how we're going to build it. That, to me, that's the challenge of creating a world of ambient computing.
That sounds very, very interesting. And for everybody who wants to read more from Allen's work, it's on the website. We'll also post your website in the notes on YouTube. Before we end, is there anything else you'd like to say in the end? Or
I think I've probably said plenty. So
okay, this has been great. I could honestly sit down with you for hours, but it's getting late and we'll have to leave. Uh, it's been a really interesting conversation, and I hope you found it very interesting for everybody who watched it. Learning about the history of Smalltalk, the history of object-oriented programming, and how all these things got together to where we are now. And what I'd like to invite you to subscribe to this channel, watch the other videos that we have. We have a lot of interesting conversations with interesting people. And I've been Alex from Mozaic Works Studios with Allen Wirfs-Brock. And until next time, I'd like to remind you to think design and work smart and stay safe.